talk. Because this talk, the slide is almost similar with the tutorial of the big data analysis. So if you have attended this last tutorial, maybe you will listen to the same thing. Okay. Deep learning is a big range. It includes lots of algorithms like convolutional neural network, recurrent neural network, and autoencoder. But most application in computer vision is about convolutional neural network or CNN. So today's talk we will focus on the CNN. And this picture shows a typical architecture of CNN. It consists of a stack of layers. In today's talk, first we will introduce what is CNN, and then we will introduce the application of CNN in computer vision. And last, I will introduce lots of work of my research group about medical image processing. First, let's see a brief introduction of CNN. The most successful CNN was first processed in 1998. It is proposed by LeCun, and it used for the digit recognition. It's about 20 years ago. And nowadays, the development of CNN is very popular. Lots of reasons cause to this phenomenon, but the most two important reason is, the first is the data. There is an ImageNet. It contains 10 million images with its labels. And another thing is the computation ability. With the development of GPU like NVIDIA, it solves the computation problem of the network. Due to these two reasons, CNN was mostly development in this year. The first work in CNN is this one. He proposed the AlexNet. This is the first CNN used for to solve the challenge, because this organizer every year this organizer will organize a challenge to about image recognition. For example, it will ask you to design an algorithm to automatically classify one image to its label. For example, decide this picture is a cat or dog. And this is the first one to attend this challenge using CNN. As we can see the development of this challenge. This is the AlexNet. Before the AlexNet, they have two challenges, and this is the error. Its error is over than 20%. But after we development, CNN, its error reduced to 16.4. Before 2012, before 2012, like 13, 14, 15, all of these winner of the challenge, all of them used CNN. So CNN became the dominant algorithm of this challenge. And another kind of we can say, at the beginning, this network is very shallow. It only has 8 layers. But until last year's challenge, it proposed 152 layers. So we can see the depth of the network is growing. Because CNN is very powerful, and we want to ask what is CNN. So first, let's see the task in computer vision. The general task of computer vision is we have an input. This is an image, and we want to get lots of output. For example, we want to get the class of this image. The previous method to solve this is it contains of 2 stages. One stage is it first extract a feature. Feature can be regarded as a vector to describe this image. Next stage is then we design a classifier to to utilize this feature to get the result we want. So this is a two-stage pipeline. But after the development of CNN, we only have one stage. That means this is the network. The network has an input, it's an image, and an output is the label we want to get. So CNN combine these two stages into one stage. And nowadays, convolutional neural networks are anywhere. For example, it's used for the image search, and it also used for the face application, like face recognition, face verification, and so on. It's also used for the self-driving car, because this topic is very popular in today, like Google or Baidu, because Baidu also wants to develop the self-driving cars. And it's also used for the medical image processing or recognize the Chinese character. First, let's see this example. This is a demo used for it's an image classification demo. For example, we click this picture and see the result of this demo. It's a little slow. Okay, let's get the result. This is the result returned by the algorithm. The algorithm is based on the CNN Picasso. It returns the label. Let's try another picture, for example, this cat. Okay. Let's try this picture. This is the label because it's very accurate. So, if you are interested, you can try after this talk. And besides above application, it also used for to process lots of images. For example, it can be disguise the Alex challenge, and it also used for to process the satellite image. This is another application. It's called image caption. So the task is give you an image. You generate one sentence to describe the content of this image. And we will see a demo in the later. And another aspect of CNN, it can be used to play games. We all know this is AlphaGo. Besides AlphaGo, the CNN can be used to play this game. Another aspect is it can be used for to transfer the style of image. For example, this is the input image. After we use CNN to process it, we get this image. So maybe many years ago, the computer will create its own style. Then let's in-depth introduce convolutional neural network. Because convolutional neural network is a special case of general neural network. A neural network can be seen. This is a multi-layer perception. It's like this. We have lots of layers. we have an input layer, output layer. Between them, we have hidden layer. We can add lots of layers as we want. And all of the computation of this network is only like this. It's a weight sum of the unit. For example, this is S1, S2, S3. So every unit is only the sum weight of these numbers. So it does not involve many complex computation. It's only about the metric dot calculation. And we have this network. We need to train the network. The train means we want to get the weight W. So generally, we use the stochastic gradient descent method to train it, because train the network can be regarded as an optimization problem. And a very famous algorithm is the band property. This is because of this algorithm, we can train the network. Without this algorithm, we can say we can't train the network. So this is the basic of the popular of CNN. And here we show an architecture of CNN. We can say CNN is a network. It has an input image and output. In this application, it's a class label. And this is the architecture. It has lots of layers, like convolutional layer, IELU layer, and pooling layers. So first, let's see a convolutional layer. We have an input image. This image its size is 32 by 32 by 3. And we also have a filter. Its size is 5 by 5 by 3. So we convolve this filter with this image. Then we can get one output. If we convolve this filter, slide around all of this image, we can get a map. We call this an activation map. Because the reason we call it a convolutional layer, this operation is very similar with the convolve in single processing. So we call it a convolutional layer. If we have another filter, we can get another activation maps. So if we have 6 filters, we will get 6 activation maps. And we want to know what's the filter want to learn. Here we show the filter. This is the input image patch. This is the filter. Filter is a 5 by 5 metric. And this is the output. We can see this output are very responsive to the edge or corner. So the filter wants to learn the edge or the corner of the image. And here we call it the convolutional because it is related to the convolve in single processing. And if we have the convolutional layer, we can construct a CNN by use lots of convolutional layers like this. This is the animation to show how the convolution works. And we can see, besides the convolutional layer, we also have pooling layer or fully connected layer. So let's introduce what's a pooling layer. Pooling layer, the purpose of pooling layer is to make the feature map or the activation map smaller. So you can regard it as the image per second with smaller the features. The operation is very simple. For example, if we use 2 by 2 filters, so we can, the input is a 4 by 4 image, we can get a 2 by 2 image. Because this is max pooling, so we find the max value of this 6. And we find the next one, max value of this is 8. So we can get this. Another layer is fully connected layer. This layer, as the name it said, fully connected. That means because the network is input, output, and busy lane. The fully convolutional, fully means this unit connected to all of this. So this is fully. Fully means it. If we want to get the value of this, we will calculate all of this unit. And if you are interested in the CNN, you can see this video. This video.
Recent advances in neural networks have enabled processes, showing what happens inside of neural nets. In the top left corner, we show the input to the network, which would be a still image or a video.
This is the input of the CNN, and this picture shows the intermediate output of CNN. So we can say the CNN wants to learn something like this.
For example, on this first layer, the unit in the center is showing images synthesized to produce information. We investigate this neuron by showing a few different types of information. And by looking at the decon, we can see that it would respond to
this is the output of convolution
and rose rhythms. We can also confirm that it carries above the head and shoulders.
So this is all thing of CNN. It's only about convolutional layer, pooling layer, and fully connected layer. After we have these 3 layers, we can construct our CNN. And use this CNN, we can challenge it. We can attend this challenge and get the surprising result. Let's see some typical architecture of CNN. This is the AlexNet, the first CNN used in the ImageNet challenge. And we can compare it with the first successful CNN proposed by LeQuan in 1998. And we can see it used more data to train it. And it also uses GPU to calculate, because if we don't use GPU, the training of this network is very slow. And it also under lots of algorithm. But the most two important is the data and the computation. This is the winner of the challenge in 1912. And this is the winner of challenge in 1930. It also uses we can say they are very similar, but it reduces the error. This is the winner of 14. It also uses CNN, and it further reduces the error. Another feature of this network is it uses very small kernel. Because we can see this is the first network. We can see the first layer it uses 11 by 11 filter. But in this network it only uses 3 by 3 filter. So the trade-off is use small and small filters. And this is the winner of 14. It also uses CNN. And it proposed this structure. They called it inception model, inception structure. It further reduced the top 5 error. A very interesting thing is, compared with the AlexNet, this network uses less parameter, but it involves more computation. And the very famous network in today is this residual network. This is proposed by Chinese people in MSRA by Kai Minghe. It's a student of Tang Xiaou. So this network is very famous. Why? Because it is very different from previous network. As we can see, before 2014, the depth of the network is only 22 layers. But Kai Ming proposed 152 layers. It doubles the depth of the network. And it also reduced the top 5 error to 3.2 this. And the technology he used is very simple. The left is the network used by others. He only under one connection. So this is the Kai Minghe's network. This is others' network. He only under this connection. This simple connection reduce the error and increase the depth. So maybe you can remember this name. By now, the network are designed to solve the image classification problem. But the CNN, besides the image classification, CNN can be used to solve other tasks. How can we solve other tasks? The basic idea is we use CNN2 as a blank block. This block takes an image as input and output a feature. Then we use this feature to do anything we want. For example, in the origin image classification problem, we under fully connect layer to get the probability of different class. And if we want to do image caption, we use RNN. This is recurrent neural network. This is another algorithm of deep learning. We can add this to generate the sentence. Let's see this demo. This is the picture, and this is the sentence it generates. For example, a man is running a house. Let's try another picture. Like this one. A large dog lying. And maybe this one. Occasionally. So it's very interesting and powerful. And if you want to get the position of the object, you can also use the fully connect layer to get the position XY coordinate. Another thing is, if you want to use for play the game, you can also use the fully connect layer. And the output is the probability of direction you should to move. Because play the game is, for example, in this, you want to decide which direction you want to move the left or move the right. So you can use this to predict the direction you move. Let's see this video. This is the program automatically play, no human. Let's see this. Another task is called segmentation. The segmentation is besides the label you want to get, you also want to get the shape of the object. For example, this is, you want to get the shape. Okay, there is also a demo. This is input and this is the result. So segmentation is different from classification, and segmentation is difficult than segmentation. Another is autoencoder. So you can use a deconvolutional layer to get the original image. If you want to use detection, you can add one by one convolution. Let's see this video. This is real-time detection, not no post-processing. So in your work, if your problem is related to the image, you can use the CNN to solve it. And if you don't use CNN to solve it, you will be bait. In the last part, I will introduce lots of work about my research about medical image processing. First, let's see the modality of medical image. I think most of you are famous with the CT or MRI. CT is a very old technique, and MRI is a newly developed technology. MRI is popular than CT because MRI is safety than CT. It no involve X-ray. And this part maybe you are unfamiliar. This is called in Chinese it's called 组织病理切片. If you learn biological in high school, I think you have this experience to get some cell from your mouth and then use the I forget the word to observe the cell. So this is the result. I think you are familiar with these two Chinese words, 苏丹红 and 龙丹紫. So I will introduce some work about my research group. The first is gland segmentation. As you can see, gland is a structure like this. The segmentation of it is useful because the morphology of this can be used to assess the malignancy degree of the cancer. So we want to get the accurate shape of the gland. And this is the benign case. This is the malignant case. This is the health one. This is the patient. So we propose a network to solve it. The network, we can see it has two branches. One branch is predict the object. Another branch is predict the control. And then we fuse them to get the final result. Another is the mitosis. The mitosis in Chinese is 有丝分裂. So the task want to give this image. You want to locate the region of mitosis. And this is the true case of mitosis. This is the false case of mitosis. Because this image is very large, so we use two networks to locate this. First, we use a sparse network to get the location of candidate. That means these are candidates, but it may be not mitosis. Then we use another network to decide whether this is mitosis or non-mitosis. These two applications are all on 2D image. But in medical image, there is most image modality are 3D volume, like MRI or CT. They are 3D volume, a slice by a slice. So, in order to solve this, a general method is to extend the 2D CN to 3D CN, because in the computer vision field, most work are 2D CN. That means it only involve operate on 2D image. In medical image is 3D volume, so we extend the 2D CN to 3D CN, and then we can use it to solve lots of tasks. Another task is lung nodule analysis, because lung cancer is the first leading cause of all of the cancer. And nowadays we use the CT to detect or prevent the lung cancer. One task is we want to detect the non-nodule. This is a non-nodule. In Chinese is 肺结核, because this can indicate whether you would get the lung cancer. So we want to detect whether this is a lung nodule. And this picture shows some true lung nodule or false lung nodule. We can see it's very hard to, because it's very similar, so it's very hard to divide it. So we propose a 3D CN to solve it, and we design 3 networks. Then we fuse the result to get it. Another task is also about MRI image. The task is we want to segment the heart from the MRI image. The purpose of this, if we get the segmentation mask of the heart, we can build a heart model, and this model can be used for like 3D printing, or it can provide useful information when you want to have a surgical when you have a surgical operate. So we also propose a 3D network to store it. So as we can see, the medical image processing is very similar with the general computer vision problem. And the reason we want to research medical image is we want to reduce the load of doctor. For example, in the lung nodule, we have lots of patients to screen. So if the doctor decide each candidate is a lung nodule is very high, it's very time consuming. So we wanted to build an automatic system to help doctor to remove some false positives. In the past, if you want to use CNN in your research, there is some particular consideration. First, because as we said, if you don't have a GPU, the training of network is very slow. So if you want to do some research on CNN, you should have a GPU. So this is the reason that NVIDIA development, he only produce the GPU, and we have to give him money because this is the only GPU we can use. AMD also produce GPU, but nowadays most of library are based on CUDA because CUDA is based on NVIDIA's card, and the AMD card is OpenCL. Most of our work are based on CUDA, not OpenCL. So we can only use the NVIDIA's GPU, not AMD's GPU. And nowadays there are lots of cluster you can use. For example, you can use the Amazon cluster. It's equipped with GPU. And if you want to say you should process, you should select a framework. There are lots of frameworks like Bay, TensorFlow, or Torch. So if you are if you only want to use CNN to solve your problem, not develop the architecture or something about CNN, I recommend you use TensorFlow because TensorFlow is developed by Google. So maybe it will, nowadays, maybe it is not popular, but in the future, it is the potential one. And another thing is, because when you want to use CNN, one important issue is how to design the architecture. The answer is don't be a hero. That means you can say what architecture perform best in this challenge and borrow it and use this architecture to solve your problems. Another thing is to design the hyperparameters. It also borrows the successful practice in the ImageNet challenge. And if you are interested in CNN, maybe you can watch this course. This course is about Stanford. It's about, maybe we can, it's about CNN. Because it has lots of TAs, so you can see you will learn more things from this course. So if you want to learn something about CNN, you can watch this course. This is another website about the CNN. Not only CNN. It's about deep learning. It introduced the complete aspect of deep learning, like CNN or RNN, because in NLP, natural language processing, most work are used recurrent neural network. This introduced RNN or TensorFlow. So if you want to have knowledge of deep learning, you can look through this website. It provides the YouTube video. Another is if you want to use TensorFlow, you can use the tutorial. Because TensorFlow is developed by Google, so it has very beautiful tutorial, and the tutorial is very detailed. So, if you want to learn something about TensorFlow, the best material is this website. In conclusion, the deep learning has no mathematics, no complex equation. It's very simple. It's only involve convolutional layer and pooling layer. So most of our research work on CNN is how can we set the parameter, and how can we use it to solve different applications. So it's have lots of aspects about engineering, not scientific. And that's it. If your research is related to the image, maybe you can try CNN to solve it. Okay, that's all the content. So any question? Or maybe we.
Since we still have time, so any question from the audience?
I want to know what kind of status of the medical images is very like. So you have provided some examples about lung cancers, etc. What is how many startups in the field are working on what kind of problems? Give some comments on these kind of things.
As we all know, because in general computer vision, there are lots of startups like Galation or nowadays Shanghai or the Huangshi C++. But in medical image, there are several startups. In China, there is a startup called DeepCare. It's established maybe half years ago, and in the world it has sorry, I forget the name. But compared with the general computer vision, the medical image has potential. But another thing about computer vision is because it's related to medical, to people's health, so it has lots of construct in this application. For example, the product should get the approval by the government. But in general, like face, you don't need to get the allowed from the government. But in medical, you should get the allowance of the government.
So normally where does it get data like those medical images?
Yeah, data set is another question of deep learning, because in, for example, like face, we can collect lots of face image, but in medical image, because the number of patients is limited, so we don't get enough image set. So compared with the general computer vision problem, the problem is limited training data set. And the data set, most are from the hospital. Another way to get the data set is attend the challenge. Because in medical image processing, there are lots of challenges. Every year there are maybe have 10 or 20 challenges. Because this challenge provides some data set, you can use this.
So your work is based on the hospital data.
Part of some work on hospital data, some work on challenge. For example, this is the challenge data set. All of the applications are the challenge data set. And our blog also has some work on hospital data set.
Thank you very much. Any other questions?
Actually, I have a question. Just now you say that in order to process the medical image, you need to extend the CNN to a 3D model. Can you explain more about it? How to extend the
Because we said the two layer in CNN is convolutional layer and pooling layer. Convolution is in 2D image. This is the input, this is the filter, and this is 3 by 3. So we get the result of this times this and this times this in 3D. So we only change the kernel to 3D, to 3 by 3 by 3, and this is a 3D volume. So we also get the result of the 27, the sum of the 27 units. So it's very straightforward to extend the 2D to 3D.
And another question is how do you design this view?
This is another aspect of deep learning. Because in deep learning there is a technique called transfer learning. For example, in the image classification, we have ImageNet. It has 10 million images. But in lots of applications, for example, in this application of stereo transfer, we don't have so many samples. So how can we solve this problem? We use transfer learning. We design an architecture very similar, for example, very similar with the residue net. And then we use the ImageNet challenge to train this network. And we copy the weight to this weight. Then we can fine-tune the network on our own dataset. So your answer is, we first, because there are some work on video, because this is a video, so there are some work use 3D CNN to solve the video problem. So we can use the weight of this network to solve our own image processing.
Thank you very much. And thank you. Let's get applause for
you mentioned that there are input layers and output lasers. So and there in the input layer there are X1, X2. So what kind of value are those X1, X2?
You mean the input?
Yeah.
We have an image. If the size is 100 by 100, then we can select this image to a 10,000 vector. So this is the X. Because image is in RGB image, so every value is between 0 and 244. So this one is maybe 1, this may be 200. So this is the rank intensity. So this is it.
So the input is a
Image.
vector.
Like it's the image after you find this image into one vector. Sorry. No, sorry, I made a mistake. In feed forward, in the feed forward neural network, the input is you plant this image into one vector. But in the CNN, the input, you don't plant it. The input is this image. The input is 100 by 100 by 3. This is the input. The 3 is RGB because you have 3 channels.
If we have an image is 2 by 2, like, so what is the input?
The input maybe 100, 200, like it.
So that's the light intensity.
Right, light input.
So what's the input? If this is an image of 2 by 2.
This, you mean what's the input?
Yes, the x1 is 2. If the picture is 2 by 2, like right?
If you want to use the favor network, the input is a vector. This is the input, so this is x1, x2, x3, x4. But if you use CNN, you don't need to change it into one vector. You directly input this. Because you have a kernel. You use this kernel to convert this.
Any questions? Okay, if not, let's send our speaker again. We have a small discussion session in the next room, and we provide a soft drink. We can have a talk in the next room.